Hi friends, welcome to GMK tutorials. Today we are going to discussing on decoders concept. Okay, decoders. Decoders are similar to the demultiplexer but without any data input. Okay, it is similar to demux. It is similar to demux without any input. Decoder is a logic circuit that converts n-bit binary input data into 2 power n output lines. Okay, it converts, that means here it converts n inputs to 2 power n output lines. Okay, so this is nothing but n into 2 power n format. Okay, these are the output side. This is nothing but input side. And each output is activated only one of the possible combination of the inputs. Okay, each output is activated only one of the possible combination of inputs. Okay, in a decoder the number of outputs is greater than the number of inputs. Okay, in a decoder we find number of outputs is greater than inputs. If suppose number of outputs is equal to number of inputs is called converter. If number of outputs equal to number of inputs is called converters. Like if you are taking example of BCD to XS3 and gray to binary, like this. Okay, so if you are taking a block diagram of 2 to 4 decoder, 2 to 4 decoder block diagram, let us see the it consisting of 1 2 3 4 two inputs and it is nothing but 2 to 4 decoder. So here the first one is nothing but input lines and second one is nothing but suppose a comma b are the input lines. This is nothing but output lines. I will consider I0, I1, I2, I3. So this is a 2 to 4 decoder. Suppose if you are taking, so the general formula is equal to again same here. If m is the selection lines, if you are taking n is the number of inputs, outputs is equal to 2 power n. So 2 square 4 where n is equal to. If n is equal to 3, outputs is equal to 2 power n. 2 cube is equal to 8. So for 3 to 8 decoder, suppose if you are taking a 3 to 8 decoder, inputs 3, outputs 8. So for inputs A, B, C, outputs D0, D1, D2, D3, D4, D5, D7 to D7. These are the possible outputs for these are the possible outputs for 3 to 8 decoder. Only only one of the output is activated for specific combination. Okay, specific combination of inputs. Okay, so let us see the truth table for 3 to 8 decoder. Let us see the truth table for 3 to 8 decoder. Okay, so what are the possible combinations of inputs, outputs? Inputs can be treated as here A, B, C. Outputs can be treated as D0, D1, D2, D3, D4, D5, D6, D7. Okay, let us see the possible combinations for input and output. So for first possible combination 0, 0, 0, D0 is activated, first one, the remaining all are zeros. For 0, 0, 1 combination, D1 is activated, remaining all outputs are 0. For 0, 1, 0 combination, that is nothing but binary equivalent of 2, only D2 is activated and the remaining all are in 0 position. For 0, 1, 1 case, D3 is activated and the remaining all are zeros. For 1, 0, 0 case, that is nothing but 4, only D4 is activated and the remaining all are zeros. For 5, 1, 0, 1 is nothing but 5 in the decimal values. So here D5 is activated and the remaining all are in 0 position. 1, 1, 0 is nothing but 6. Only D6 is activated and the remaining are in deactivated. So last one is nothing but 7, 0, 0. Only D7 is activated, remaining all are in deactivation position. So this is nothing but truth table for truth table for this is a truth table for 3 to 8 decoder, right? Truth table for 3 to 8 decoder. So 3 to 8 decoder. So this is first one, This is also activated. The circle represents are the activated. These are all in the diagonal combination only, right? Okay, last one is also activated. Okay, so that is the activated. So this is a truth table for this decoder. Suppose if you are representing the logic expressions for the output, D0 can be represented as logic expressions for the decoder. We can write like this. D0 is equal to, what are the possible combination? D0 is activated only A bar, B bar, C bar combination only. So under D1 is activated for A bar, B bar, C combination. And D2 is activated for A bar, B, C bar. And D3 is activated for A bar, B, C. And D4 is activated for A, B bar, C bar. And D5 is activated for A, B bar, C. D6 is activated for A, B, C bar. D7 is activated for A, B, C. Okay. The three inputs A, B and C are decoded into 8 outputs, each output representing one of the minterms of the three input variables, right? So the decoder can be used for decoding any 3-bit code to provide a 8 outputs. That means it converts, right? It converts 3 to 8, right? So that means 3 inputs are converted to 8 outputs, right? So this is also called as 1 of 8 decoder. Okay, it is also called as 1 of, it's also called 1 of 8 decoder. Okay, that means only one of the 8 outputs is activated at a time. Okay. Moreover, suppose some of the decoders also having a enable pins. Okay, enable pins is also important. Enable pin. If the decoder, if the decoder is having enable pins, whenever enable is high, at that time only decoder works properly. So this is very important. Decoder is only working properly if the enable pin is consisting, if the enable is in active high condition. Okay, this is the decoder's concept. Okay, the decoder consisting of, if suppose it consisting of an enable pin, let us, I will represent here enable pin. Okay, so I will explain in Telugu also. Okay, so what is meant by, coming to very brief introduction? So decoder. So decoder is nothing but it is similar to the demultiplexer. Okay, demux is nothing but which converts one to many. Here also same thing. Decoder also converts from suppose n number of inputs there. It can be represented as a 2 power n output lines. Only one of the output is activated at a time based on the input combinations. If you are selecting the proper input combination, only one of the output in the 2 power n output lines is activated. Each output is activated only one of the possible input combination. The number of outputs is greater than the number of inputs. Okay, that is also very important point. In case if the number of outputs is equal to the number of inputs, మనం ఏమంటామంటే it is nothing but converters like BCD to XS3. BCD లో మనం తీసుకుంటాం 4 numbers తీసుకుంటాం. XS3 consisting also same number of bits. That's why it is nothing but a converters or creative binary converts. So comes under like this. Okay, so if you are taking a 2 by 4 decoder, it consisting of a 2 inputs and 4 output lines. Only one of the output line is activated for corresponding input combinations. Okay, so that is nothing but 2 by 4 decoder. Suppose if you are taking a 2 by 4 decoder, what are the possible combinations? Obviously we consisting of a 4 possible combinations: AB 0 0 0 1 1 0 1 1. In this only one of the is activated. Suppose if you are taking D0, D1, D2, D3, only one of the output is activated for 2 to 4 decoder. Suppose this is 1 for first combination, remaining all are 0. For second one, D1 is activated. For third one, D2 is activated. For fourth one, only last one is. So this is a truth table for truth table for 2 to 4 decoder. Okay, so this is how the number of input lines related to this output lines. So let us see that this is a 3 to 8 decoder consisting of 3 inputs, and in case of the 3 to 8 decoder, what are the possible is it consisting of 3 input lines, outputs are 8. It consisting of A, B, C are the inputs, D0 to D7 are outputs. Okay, so only one of the output is activated for specific combinations of the input. So the truth table for this one is, this is the truth table for 3 to 8 decoder. These are the possible combination. This is the min terms we are representing for corresponding. Okay, so D0 is activated for this combination. D1 is activated for A bar C combination. D2 is activated for this combination, and D3 like this. So like D4 is activated for this, D5, D6, D7. These are all activated based on the corresponding input combination. So it is also called as a 3 to 8 decoder or a 3 to 8 converter. Okay, it is also called as a 1 of the 8 decoder. In case if the decoder having a enable pin noted, that pin must be high, then only this decoder works properly. Okay, that is nothing but decoder. Okay, coming to the decoder applications. Okay, applications, it is used in many applications. Suppose I will mention some of the applications in microprocessor memory system, selecting the different banks of the memory. Okay, let us see the applications of the decoder. Applications of decoder: selecting different banks of memory, selecting different banks of memory, selecting different devices. In case of the selecting, if you want to selecting the different inputs and output systems at that time, this is used for selecting different devices. Okay, selecting different devices. So in that also we are using the decoders, and enabling different functional units. If you want to enable different functional units also, we are using enable different functional units. In that also we are using the decoders and enabling different rows of memory depending on the address. It is used in the memory chips applications, memory chips application, enable different rows of memory depending on address. Okay, these are all the possible applications for decoders. Okay, so with this I will conclude the decoders topic. Okay, thank you for watching GMK tutorials. Thank you for your support.